Hello, it's Mrs. Stipe. We're going to knock out two sections in this video. First one's super simple. It's how to use your calculator, okay? So I wish I had a TI emulator up here, but you'll just have to follow along with my words. Much of this you know already. If you have a 32-degree angle and I ask you to take the sine of it, you simply plug in sine 32 degrees. You should get 0.53. It will most likely say to round to hundredths. Okay. If you don't get that when you put that in your calculator, you need to go to mode and change the mode to degrees. For right now we're in degrees, and a little bit we'll talk about radians. Perfect. What about though if the sine is missing? What about if the angle is missing? And I say to you, I don't know the angle, but I know that the ratio of the sides, the sine ratio is 0.2. So this is when we use those buttons above the sine, cosine, and tangent, and we type in inverse sine, sine to the -1 of 0.2. And what that gives us is an angle degree measure, and so you want to make sure that your answer has a degree sign on it. If it doesn't, then it's very confusing. Okay, we run into a little bit of trouble when we talk about the reciprocal functions because there are no keys for the secant, the cosecant, and the cotangent. All right, so how do we do that? Well, it's not that tricky. If I say that I want the secant of a 50-degree angle. By definition, we know the secant is 1 over the cosine. So here's all we need to do is type in 1 divided by cosine 50, and we get 1.56 is our secant of a 50-degree angle. All right, let's try one more. If we want the cosecant of an 85-degree angle, we type in 1 over the sine of 85 degrees, and we get 1.02. Okay, pretty straightforward. This is where it gets a little challenging. What about if the angle's missing? But we know that the cosecant of the angle is equal to 7, all right? So we want to make sure we flip in the right order. So the first thing we have to do is say that's the same thing as saying 1 over the sine of theta is 7. Therefore, the sine of theta is 1/7. All right? So if we take the inverse sine of 1/7, we turn out to get 8.21 degrees. Okay, that's really all of Chapter 2, Section 2. Let's move on to Section 3 of Chapter 2, and this is about solving right triangles. What that means is that you're going to find the missing sides. Ooh, boy, I combined that. Missing sides and angles of right triangles. And we're going to use SOHCAHTOA for these, all right? Before I do that, I need to add a note here to talk about parts of degree, because we don't always, when we measure an angle, have full degrees, right? So what if we had 35.5 degrees? Right, or 35.5 degrees. Well, no problem. We could put this in our calculator like that. But parts of degrees are measured in minutes, and you should remember this from the geometry book. And so what you need to remember is 60 minutes equals 1 degree. All right? So if I tell you I have 72 degrees 14 minutes, really important, that is not equal to 0.14. So don't even think that that's 72.14. All we need to do is say what's 72 plus 14 over 60, and that would be a calculator problem, and we would get 72.23 degrees. All right, so something to remember as we go on into the next section. You'll have some problems that have minutes instead of decimal part. All right, here we go. Setting up the right triangle. We can pretty much always count that the right angle is going to be called C, and the two acute angles are going to be A and B. Sometimes they mix the letters up, but this is always true. Opposite angle A is little side A, opposite angle B is little side B, and the hypotenuse opposite angle C is little c. So I'm going to give you pieces of information, and you're going to find missing parts. So if I say the measure of angle A is 42 degrees and C is 7, and your job is to find A, you need to set up a trig equation and solve it to find A. So what you want to do is you want to say I have angle A, I'm I have little side C and I'm looking for A, and so from angle A, this is clearly opposite over hypotenuse, so you would write sine of 42 is equal to A over C. C is equal to 7. Right? So one step to solve this, multiply both sides by 7. So you would put in your calculator 7 times the sine of 42, and you would find that 4.68 units is how long A is. Make sure you're clear that you're not putting degrees when you're finding a side measure, and when you're finding an angle, definitely put the degrees. All right, sometimes when we set up the trig function, we don't know the variable that's missing is in the denominator. So let's go back and look at the triangle up here again and say this time that we'll say angle B is 25 degrees, and we're going to say that A is 7, and we want to find C. All right, so from angle B, A is adjacent, so I'm going to say cosine of B is equal to 7 over x. So what happens when x is in the denominator, instead of just one step like up here to solve the equation, we actually have to do 2 steps. So the first step is to get that x out of the denominator. So we get x cosine B equals 7. Second step is to divide both sides. Ooh, I said that B was 25, so I should probably put 25 in here. Put that in your notes. That was careless. So the x times cosine B is cosine 25 is 7, so now I'm going to divide both sides by cosine 25, and I end up getting x is equal to 7.72. All right, so some people don't need to do the 2 steps. They just recognize that when x is in the denominator, the way we solve it is we take the numerator divided by the cosine value. Probably you'll do enough of these that you'll be able to do the shortcut too. Okay, let's do one last problem, and this time the angle's missing. So let's go back to our triangle, and we'll call this A, this B, C. And we're going to be told that the sides A is 5 and B is 7, and we want to find angle A. All right, so from angle A, here's B. A and B are the opposite and adjacent, so we know that its tangent of A equals 5 over 7. So back to the top of this, when the angle is missing, we ask the calculator to tell us what angle has a tangent of 5/7, and we put that into our calculator, and we get 35.54 degrees. All right, so in class we will practice a lot so you're comfortable with your calculator, and we'll also practice doing solving right triangles. All right, great. See you in class.